Welcome to this episode of On the Moon. I'll be your host today and we're talking about the Intuitive Machines IM-1 mission, a historic leap for commercial lunar exploration. On February 22, 2024, Intuitive Machines, a Houston-based space exploration company, etched its name into the annals of space history with the successful landing of its Nova C lunar lander, named Odysseus, on the Moon's surface. The IM-1 mission, part of NASA's Commercial Lunar Payload Services (CLPS) initiative, marked the first American soft landing on the Moon since Apollo 17 in 1972 and the first ever by a commercial entity. Despite challenges during landing, the mission delivered significant scientific data and demonstrated the potential of private companies in advancing lunar exploration. This article explores the IM-1 mission's objectives, execution, challenges, and its broader implications for the future of space exploration. Mission objectives and design. The IM-1 mission aimed to deliver a suite of scientific and commercial payloads to the lunar surface, specifically targeting Malapert, a crater near the Moon's south pole, approximately 300 kilometers from the pole. The Odysseus lander, a hexagonal cylinder standing 4.3 meters tall and 1.57 meters wide, was designed to carry up to 100 kilograms of payload. Powered by solar panels generating 200 watts and utilizing innovative liquid methane and liquid oxygen (methalox) propulsion, the lander was a technological marvel built for precision and efficiency. This propulsion system, tested extensively at Intuitive Machines' Houston facility in Spaceport America, was the first of its kind used for Earth-Moon navigation, highlighting the company's focus on sustainable and robust space technologies. The mission carried 12 payloads, including 6 NASA instruments and 6 commercial ones, ranging from scientific experiments to artistic installations. NASA's payloads focused on studying plume surface interactions, radio astronomy, space weather, and precision landing technologies, critical for future Artemis missions. Commercial payloads included a student-built camera, EagleCam, from Embry-Riddle Aeronautical University, a data archive, and a small astronomical telescope. The mission's overarching goal was to gather data to support NASA's Artemis program, which seeks to establish a sustainable human presence on the Moon by the late 2020s. Journey to the Moon. Launched on February 15, 2024, at 1:05 a.m. Eastern Standard Time from NASA's Kennedy Space Center aboard a SpaceX Falcon 9 rocket, Odysseus embarked on a 620,000-mile journey. After separating from the rocket's second stage, the lander achieved stable attitude, solar charging, and communication with Intuitive Machines Mission Control in Houston. A series of trajectory correction maneuvers ensured Odysseus entered a 100-kilometer lunar orbit on February 21. However, the mission faced a significant hurdle when the lander's laser rangefinders failed, forcing engineers to rely on NASA's Navigation Doppler LiDAR, NDL, originally a technology demonstration, for velocity and altitude data during descent. This last-minute adaptation underscored the mission's adaptability and the critical role of NASA's partnership. The landing and its challenges. Odysseus touched down on February 22 at 6:23 p.m. Eastern Standard Time, but the landing was not without complications. Due to the navigation issue, the lander descended faster than planned, landing 1.5 kilometers from its target in a 1-kilometer wide crater with a 12-degree slope. The impact broke at least one landing leg, causing Odysseus to tip over and rest at a 30-degree angle. Despite this, the lander remained operational, transmitting data from most of its payloads. The tilted orientation limited solar panel exposure, reducing the mission's operational timeline from the planned 7 to 9 days to about 6 days, ending on February 28 when sunlight no longer reached the panels. Communication challenges further complicated operations. Initially, only a weak signal was received, requiring assistance from NASA's Deep Space Network to establish stable contact. The team reconfigured antennas to improve data rates, ultimately downloading over 350 megabytes of data, including guidance, propulsion, and scientific payload information. While the EagleCam payload could not be deployed as planned due to software adjustments, most NASA and commercial payloads achieved their objectives, marking the mission as a technical success despite the rough landing. Outcomes and significance. Intuitive Machines and NASA hailed IM-1 as an unqualified success for achieving its primary objectives, a soft landing and data transmission. The mission demonstrated the viability of commercial lunar landings, a significant milestone given the failures of prior private attempts by CLPS, and Astrobotic. The data collected, particularly from NASA's payloads, will inform future lunar missions, including Artemis 3, by providing insights into the lunar South Pole's environment, a region rich in potential water ice resources. The mission also showcased the resilience of the Nova Sea lander and its Methalox propulsion system, which survived forces beyond its design specifications. Intuitive Machines' ability to troubleshoot real-time issues, such as the navigation system failure, highlighted the company's technical prowess and set a precedent for future missions. The IM-1 mission's success bolstered confidence in the CLPS program, which aims to leverage commercial partnerships to reduce costs and accelerate lunar exploration. Looking ahead, the IM-1 mission's challenges provided valuable lessons for Intuitive Machines' subsequent missions. IM-2 and IM-3, launched in 2025 and planned for late 2025 or early 2026, respectively. IM-2, which also faced orientation issues, built on IM-1's experience by incorporating additional cameras to better assess lander positioning. These missions continue to refine technologies like the Prime 1 drill for in-situ resource utilization, critical for sustainable lunar operations. The stock market initially reacted negatively to IM-1's landing issues, with Intuitive Machines shares dropping over a third on February 26, 2024. However, the mission's overall success and the company's transparency restored investor confidence, with shares later recovering. The mission also sparked public and industry enthusiasm, reinforcing the United States' leadership in commercial space exploration. Conclusion. The Intuitive Machines IM-1 mission, with its Odysseus lander, was a groundbreaking achievement that bridged government and commercial efforts in lunar exploration. Despite a challenging landing, the mission delivered critical data, validated innovative technologies, and paved the way for future private lunar missions. As Intuitive Machines prepares for its next voyages, the lessons from IM-1 will continue to shape the cislunar economy, bringing humanity closer to a sustainable presence on the Moon and beyond.